Good morning, children. I welcome you all to today's session of physics, and we are on to chapter force and pressure. Right? See, children, in this chapter we will be studying about these two very important parts of physics, which are force and pressure. Children, when we want to open a door, we have to push the door handle with our hand, and when we want to close the door, we have to pull the door handle with our hand. This means that to move an object, it has either to be pushed or pulled. A push or pull on an object is called force, right? Please, you need to remember this. This is the definition of force. A push or pull on an object is called force, right? The direction in which the object is pushed or pulled is called the direction of force, right? So if we are opening the door inside, that is the force, the direction of the force is inside. If we are pushing anything outwardly, that means the direction of force is outside. We open or close a door by applying force, right? Now, when we push the door to open it, then we apply a force on the door in a direction away from us. And when we pull the door to close it, then we exert a force on the door in a direction towards us, right? So, before we go further, we should know the meaning of the term interaction. Right? Interaction means reciprocal action. Interaction involves two objects. In interaction, each object acts in a way as to have an effect on the other object. Right? See, children, in this diagram here, you can see one person is exerting the push, the other one is exerting the pull. Right? So, both of these are part of force, types of force. Right? So force is always due to an interaction. Interaction of one object with the another object results in a force between two objects. In other words, a force arises due to the interaction between two objects. Right? At least two objects must interact with each other for a force to come into play. Right? And these are the few examples. Right? Next we move to moment of force. Right? A moment of force is a measure of its tendency to cause a body to rotate about a specific point or axis. That means the body will be fixed from one point and the other end will be moving, right? So let us try to understand this definition of moment of force, right? Okay. Now, this moment of force is also termed as torque, right? It is also termed as torque. This is different from the tendency of a body to move or translate it in the direction of the force, right? So for a force you need push and pull, there will be a complete displacement of the object. But in torque, as one end is pivoted or is joined, so the only the other end will move, the other, right? One end will be fixed here, right? For example, door, right? It is the handle, it is the a part near the handle which moves, and the other side of the door is fixed, right? See, these are called hinges. As you can see here, these points are called the hinges, right? This is one hinge and this one is the other hinge, right? Now we go to here. What happens is, see, if we want to open or close it, then the force is applied perpendicular to one of its edges, whereas another edge is held in the nut. The center of the nut acts as a pivot, and the perpendicular force creates a movement or turning effect, right? The force will cause a turning effect only if lines of force act perpendicular. Now, what is the elements of a moment? The magnitude of a moments of the force is directly proportional to the distance of the force from the point of axis, right? So if the force is F and the moment is D, then moment of force will be, see children here, the moment of force will be M is equal to F into D, right? We will multiply the force with the distance, right? Now, the unit of force is Newton, right? See, the unit of force is Newton and the unit of distance is meter. So the SI unit of moment of force will be Newton meter, right? Newton meter. Now there are a few numericals here. See, if the force of 100 Newton is applied on the spanner of at a distance of 10 centimeter from it. So see, what has been done here is the distance which was in centimeter has been changed into meter, and then it has been multiplied with the force, right? Then it has been multiplied with the force, right? And there are a few examples here. Next we come to pressure. Pressure is produced when a force acts on an object. In most cases, an object exerts force on another object by making contact with it, right? See, in this area, in this two examples, you can see that with the thumb and a pressure is applied on an area. See, the area is large of the thumb, and so a very small pressure is applied. Now, if we take a drawing pin and we apply the same pressure, then as the area is very small, hence the pressure will be very large, right? This is being demonstrated here, right? So drawing pins, because see, the drawing pins edge, bottom edge is very sharp, right? So there will be a lot of pressure at that point, and hence that is why a nail or a drawing pin enters into the cardboard easily, right? So this is the formula of pressure, and the pressure is generally called as the force acting on a unit area, right, is called pressure, right? So the unit of pressure is called Newton per meter square, or called Pascal, right? Newton per meter square, or called Pascal, right? Then there is kilopascal also. And see, there are some examples here. Force is of 100 Newton and applied on an object of area 2 meters square. Then you are asked to calculate the pressure. So we put it and we get 50 Pascal as the pressure, right? Okay. Now, from this formula, we can make through that the pressure is directly proportional to force applied and area over which the force acts. These are the two things on which pressure is dependent upon. So that means if the force is large, then the pressure will be large, or if the area is small, then the pressure will be large, right? If the area is large, then the pressure will be small, right? See, an example of that is that weight of a body is also a force, and it always acts in a downward direction. The explanation of some everyday observations on the basis of pressure. We can see a school bag for a shoulder has wide strap made of thick cloth canvas, so that the weight of the bag may fall over a large area, right, of the shoulder of the child, producing less pressure on the shoulder, right? And due to the less pressure, it is more comfortable to carry the bag, right? We have also seen that. We have also seen that, right, in our classes. A sharp knife has a very thin edge on its place, right? Because it, the thinner the area will be, the lesser the area will be, the more will be the pressure, and more will be the pressure, so it will be easy to cut anything, right? As is shown in this diagram here. When a man stands on a cushion, then only his 2 feet are in contact with the cushion. Due to this, the weight of the man falls on a small area of the cushion, producing a large pressure. This large pressure causes a big depression in the cushion. On the same hand, when the same man is lying on the cushion, sleeping over it, then the whole body is in contact with the cushion, and in this case, the weight of the man falls on a much larger area of the cushion, producing a much smaller pressure. And this small pressure produces a very less depression, right? The tractors have broad tires, right? So that less pressure they put on the ground and the tires do not sink into comparatively softer grounds of wheels. A wide steel belt is provided over the wheels of army tanks so that they can exert less pressure on the ground and do not sink into. Wooden sleepers are kept below railway tracks so that less pressure on the of the train is on the ground and the railway line may not sink into the ground, right? So on and so forth. Now we come to the pressure exerted by liquid, right? All the liquids have weight, so when we pour a liquid into a vessel, then the weight of the liquid pushes down on the base of the vessel, producing a pressure. We say that the liquid exerts pressure on the basis of vessel, right? Figure shows vessel containing a liquid. The weight of the liquid is pushing the base of the vessel and exerts a pressure on the base. This pressure is the formula pressure is equal to force upon area, right? So we will see what is this dependence of pressure on depth of a liquid. The pressure in a liquid is not the same at all depths. The pressure exerted by a liquid changes with the depth of the liquid. Actually, the pressure exerted by a liquid increases with increasing depth inside the liquid. The pressure exerted by a liquid is small, just under the surface of the liquid, but as we go deeper into the liquid, the pressure of the liquid increases. Actually, as the depth of the liquid increases, the weight of the liquid column is pushing down, and hence the pressure will also increase. So let us stop here, and I hope you enjoyed it as much as I did in making it. Until we meet again, it's a goodbye.